For our random science facts, part 6, let's discuss why blue LED lights were almost impossible to make back then and how crucial it is. I know you are familiar with this since a lot of edits about blue LED lights have been spawning on our FYP page for the past couple of days. People don't understand this, but blue LEDs were basically the Thanos of lighting technology. Red and green LEDs were invented way earlier. They were glowing happily in the 60s to 70s. But blue LED was the reason scientists were losing sleep, hairlines, and probably their sanity. Here's the thing. LEDs work by using a semiconductor that emits light when electricity passes through it. Different semiconductor materials create different wavelengths of light, which our eyes perceive as colors. Red and green LEDs were easy because scientists had materials like gallium arsenide, gay ass, and gallium phosphide, gay p. Gallium arsenide naturally emits red infrared. Gallium phosphide can emit green and yellow. These materials were stable, easy to grow, and behaved well in the lab. No drama. But for blue light, you need much shorter wavelengths, which means the semiconductor needs to release higher energy photons. And the only material that could theoretically do this was gallium nitride, GaN. And gallium nitride was a nightmare. This material fights for its life every time you try to work with it. Scientists struggled for decades because growing GaN crystals was almost impossible. It cracked. It formed defects. It refused to form smooth layers. It was like trying to bake a cake with sand. If red and green LEDs were microwave popcorn, blue LED was make a gourmet souffle on a boat during a storm. You couldn't dope it properly. To make a semiconductor work, you need to add impurities, like magnesium, so electricity can flow. Gallium nitride kept saying, nope, not absorbing that. Next. The impurities stayed inactive until scientists realized you had to blast the material with low-energy electron beams or anneal it under nitrogen just to get the magnesium to wake up. Imagine having to punch your LED into working. It resisted manufacturing. Gallium nitride didn't want to stick to the usual wafers used for semiconductors. They eventually discovered they had to grow gallium nitride on sapphire, which is expensive and unstable, before it even started working properly. Then, finally, in the early 1990s, Akasaki, Amano, and Nakamura figured it out. They cracked the code. They activated the doping. They stabilized the growth of gallium nitride. They literally dragged the blue LED into existence. They won the 2014 Nobel Prize in Physics because this wasn't just another invention. This was a universe-changing discovery. Here's why. Red, green, and blue are the primary colors of lights. Additive color mixing. Mix them in corresponding combinations, and you'll get yellow, cyan, and magenta. And here's the most crucial part. Mixing red, green, and blue will result in white light. Before blue LEDs existed, we only had red and green. That means we could only make very limited colors. No white, no full RGB, no realistic screens. Screens today work because every pixel is made of tiny red, green, and blue sub-LEDs. Without blue, everything would look like a Game Boy from 1989. So yeah, blue LED wasn't just a color. It was the final infinity stone of modern technology. Red and green were easy. Blue was the diva. Once blue finally joined the group, RGB was born. White LED light became possible, power-efficient lighting took over the world, and your entire modern lifestyle basically turned on. Zeke out.